BluntCut MetalWorks, August 9, 2021. This is Zmax 67.5 Rockwell. Sharpened using an edgepro at 7 degrees precise. Finish edge at 1200 grit diamond waterstone. And so the edge is pretty clean. The objective of this test is to see, with my metal sequencing research, is see how well I tested other metal, other steel, but this steel has 10% cobalt, and I want to see how cobalt responds to my sequencing. And basically also checking, see at the extreme, I mean at 7 degrees precise, that's thinner than straight razor edge, so that cutting into hard material, man, will damage it. But we'll see that whether or not the cobalt, I mean from the cobalt matrix, that will give it that toughness, but also limit the matrix strength to about 45 Rockwell or less, 45 to from 40 to 45. But anyway, so we'll see how it does, and get doing some cut of cardboard. I'm just going to judge from the look here. I don't see any sort of light that show me that there's a rippling. I mean the edge is ripple, possibly a tiny bit of something. But anyway, I'm going to use with this really soft wood here, and I basically push it forward, so you can see the really curved, wonderful fun. I'm going to pull it, right? And all I'm doing less careful. Again, this is really soft wood, and I'm going to do from less destructive to more destructive. I'm going to just cut up these back four of the half-inch scissor rope. If it's not strong enough, it will already collapse after, first cut. Usually if you take a straight razor and do one cut like this, the straight razor won't make a second cut. It's going to just die. Anyway, let's do a quick check. Do I feel something? Check the edge real quick. There's something there. As long as, we'll take a close look, but I can see actually some of the rippling effect. Anything I think below 8 degrees precise, or actually below 10, I would say 9 or below, the very sharp apex, I mean because of the keenness there, it's very easy for it to kind of bend over a little bit, and then when you push down from the cutting, then it's going to that deflection there could be going both directions, so you have rippling effect. And then when the ripple it bend a little bit both sides, then now continue pushing it. If you push it more, it can bend more, or because just like you bend a stick, it gets stronger feel to it, and so that's why the additional thing will not it's still got the hole. It's that shape. But right now, there's that's why you cut in the phone book. You feel that a little bit there. And this is just a disposable bamboo chopstick here. And I put where the D is, I guess. Okay. So you can see that it cut just fine. And now I'm going to try the soft end of cooked dry pork rib bone. This is soft. I'm going to cut it simply at the just compound on the where I cut the bamboo. Alright, and where the I guess D and the P, I guess that's where I cut in there. And now on the, you can hear the sound. That means there is, this is a hard part of the rib bone here, especially on this ridge, thick. So I'm going to whittle. And definitely I see some that's a lot of folding. When you fold it and you push it hard into the bone like this, yeah. Well, and it's right there with the D and the P. Let's take a close look. After with a really hard whittle of cutting the pork rib bone, and you can see clearly these are chips. And you can see the chip line here, and then you can clear surface here, fracture surface. But what I'm looking for in terms of the cobalt response is that whether the cobalt be part of the matrix that give it more plasticity, or they transform to something else. From this result, there's no conclusion. I couldn't draw anything except you can see the edge here is deflected. Here, when it deflects toward you, you can see those deflect toward. You can see the how the shade is darker because the light scatter away, and then though that deflect on the other way. But these things didn't allow that much deflection, except for when you cut like bamboo over here. You can see that some brightness and darkness. That means it's just rippling along here. And so, and at this very small level. So as earlier in the video, I point out that when it bends, if you bend and you press so hard on it, the modulus of elasticity is not going to support that. They're going to end up with fracture here. Thanks for watching.